52 times faster. That is what Subquadratic reported at 1 million tokens on May 5, 2026. 4 people, $29 million. No published weights. Every model you have shipped, benchmarked, or invoiced this year runs on an architecture that was decided in June 2017. Not discovered. Decided. The assumption is that attention must be quadratic. Every token compared to every other token. O of n squared. The research community called it physics. It was not. 12 million tokens. That is SubQ's context window. GPT 5.5 runs 128,000. Hold that gap. The reason it is possible at all is the thing every prior attempt got wrong. I will tell you what SSA actually does differently in a moment. But the skeptics showed up within hours, and one of them used the word Theranos. The architecture wars have started. June 2017. 8 researchers at Google Brain published "Attention is all you need." They did not invent attention. They proved you could build a competitive sequence model using only attention, with no recurrence. Ashish Vaswani was the lead author. The paper had 7,000 citations within 2 years. It is the most cited ML paper of the decade. The math is not subtle. Standard self-attention computes a dot product between every token and every other token. If you have n tokens, you perform n squared operations. Each layer, each forward pass. At 128,000 tokens, the context length you get with GPT 5.5, that is 16 billion pairwise comparisons per layer. Scale to 1 million tokens, and that number becomes 1 trillion per layer. Your H100 is not slow. The math is expensive. This is the villain. Your context window is not limited by memory. It is limited by how much you are willing to pay for quadratic compute. The model vendors know this. They marketed the ceiling as a feature. If SubQ's numbers hold under independent replication, the long context pricing floor just moved by a factor of 9. That changes which workloads are economically viable. This is not the first time someone announced the death of quadratic attention. Mamba was the most credible. Albert Gu at Carnegie Mellon published it in December 2023. State space model. True linear complexity. Incredible theoretical properties. And then the benchmarks landed. At small scale, Mamba matched transformers. At frontier scale, 70 billion parameters and above, it did not. The gap was not catastrophic. It was consistent. The pattern repeated. RWKV, RetNet, DeepSeek, Sparse. Each one hits linear complexity on paper. Each one underperforms at frontier scale or cheats by mixing in standard attention layers, which reintroduces the quadratic cost through the back door. We do not fully understand why pure subquadratic architectures underperform at frontier scale. The prevailing theory is that dense attention carries implicit inductive biases that alternative mechanisms have not learned to replicate. That is an active research question, not a settled one. This is the graveyard SubQ is walking into. And the difference in their approach is specific. Justin Dangiel is a 5-time founder who last worked in health tech. Not an ML researcher. His CTO, Alex Whedon, ran generative AI at Tribe AI after leaving Meta. The team has 11 PhD researchers from Google, Meta, Oxford, Cambridge, and ByteDance. The team's CTO is Alex Whedon, former head of generative AI at Meta, $29 million seed round with backing from Justin Mateen, Tinder co-founder, and Javier Villamizar from SoftBank Vision Fund. Now the architecture. Standard attention computes attention between every token pair. SSA, subquadratic sparse attention, starts from a different premise. Most of those comparisons are wasted. Rather than asking every token to attend to every other token, SSA asks the model to learn which comparisons matter, then computes attention only over those positions. The selection is content-dependent. The model decides where to look based on meaning, not position. The key claim is that this selection has sublinear growth. As your sequence gets longer, the number of attended positions per token grows at less than O of n. Attention compute becomes near linear overall. What this means for you as a developer is that if SSA generalizes, the cost curve for long context inference stops looking like a wall and starts looking like a ramp. Your bill for processing a 500-page legal contract drops by an order of magnitude. SubQ Code, their CLI tool, loads an entire codebase into a single context pass. No chunking, no vector databases, no multi-agent coordination overhead. If your repo is under 12 million tokens, it fits. Picture this. You are a senior engineer inheriting a 6-year-old microservices codebase. 3 teams. No documentation. Right now you spend your first week reading code and asking questions. With SubQ Code, that week becomes an afternoon. Now the part where the skeptics arrived. SWE-bench verified score, 81.8%. Claude Opus 4.6 is at 80.8. DeepSeek 4.0 Pro is at 80.0. SubQ edges both on the benchmark you care about most if you are shipping software. On long context recall, MRCRV2 at 1 million tokens, SubQ scores 65.9%. Gemini 3.1 Pro, which also claims 1M context, scores 26.3%. GPT 5.5 is not even in that row. It cannot process 1M tokens. The prefill speedups are the most striking numbers: 7.2 times at 128,000 tokens, 13.2 times at 256,000, 23 times at 512,000. 52 times at 1 million. That curve is not linear. It gets more valuable the longer your context. The speedup is superlinear. The benefit compounds as context grows. That is the architectural signature of a genuinely subquadratic system. If you could fake it, you would not see this curve. Within hours of the announcement, the AI research community split. AI commentator Dan McAteer posted the line that defined the debate. SubQ is either the biggest breakthrough since the Transformer, or it is AI Theranos. The legitimate objections are 4. No full technical report, no open weights, no third-party replication, and the benchmarks come from Subquadratic's own paper. The counterpoint came from AI researcher John Rosana, who pushed back on the Theranos framing specifically. This is just subquadratic attention done well, which is very meaningful for long context workloads. The odds of it being fabricated are extremely low. Here is the distinction that matters if you are evaluating this as an architect. Mamba was trying to replace the transformer entirely. SSA is making attention itself more selective. That is a narrower claim, and narrow claims are easier to validate. The Theranos comparison is not fair and it is not useful. Theranos had no working product. SubQ has a CLI, an API, and benchmark numbers that follow a physically plausible curve. That does not make it proven. It makes it worth your attention. If you are an engineer deciding right now whether to build a RAG pipeline, a vector database layer, or a document processing workflow, this changes your calculus. RAG was invented to work around the context window wall. Retrieve only what fits, then generate. Every RAG pipeline you have built is a workaround for O of n squared. If that wall disappears, your retrieval layer becomes optional. If SubQ generalizes, the architecture collapses to this. I am not saying deprecate your Pinecone account today. SubQ is in early access, weights are closed, and third-party validation has not landed. What I am saying is, do not commit to a 12-month RAG build without checking this in 60 days. The industries where this unlocks real value are specific: legal review, clinical trial data, financial audits, code bases, any domain where the relevant information spans hundreds of thousands of tokens, and you currently solve it with expensive retrieval pipelines. Each of those domains has teams right now spending engineering weeks on retrieval pipelines that a 12 million token context window makes unnecessary. If you are on one of those teams, the return on investment math on SSA is very direct. Here is the structural bet Subquadratic is making. The major labs are locked into the transformer. OpenAI, Anthropic, Google. They have trained trillions of tokens on quadratic attention. Their pre-training infrastructure assumes it. Their fine-tuning pipelines assume it. Switching costs are enormous. You cannot retrain GPT 5.5 on SSA next quarter. This is the opening a small team needs. Not better hardware, different math. The Transformer paper did not discover the best way to do attention. It discovered a good way that worked on 2017 hardware and 2017 training budgets. The field then spent 9 years treating that pragmatic choice as a law of nature. The full model capability picture as it stands today. SubQ is competitive on every standard benchmark, leads on long context retrieval, and its architecture is the only one where the advantage compounds as context grows. SubQ at a glance. Do not hype this. Do not dismiss it because the weights are closed. 5 things for you to do before committing to a long context architecture in 2026. 1. Apply for early access at SubQ.ai. If your workload is long context, you want to be in the first cohort testing it. 2. Set a 60-day calendar reminder to check for the full technical report. The teams building on long context right now are making a bet on the architecture cycle. The question is whether you are betting on the current generation or the next one. 52 times faster. That was the number we opened with. It is not a benchmark score, it is an architectural signature. Quadratic attention gets slower as context grows. Subquadratic gets more efficient. That is what the graveyard of Mamba and RWKV could never demonstrate. SubQ claims it can. The Transformer authors did not discover physics. They made a pragmatic choice in 2017 that the industry canonized. The 4-person team in Miami is betting that assumption was never load-bearing. We will know in 90 days. Next episode. Kimi K 2.6 scores 58.6 on SWE-bench Pro and beats GPT 5.5. It is open weight. A 1.6 trillion parameter MoE from a Chinese lab that most of your colleagues have never heard of. That gap in awareness is your edge.